Hello and welcome to Leetcodes. Today we are going to see Leetcode problem, reordered power of 2. Let's dive in. We're given a number n, and we're allowed to reorder its digits any way we like, but we cannot have a leading 0. The question is, can we reorder the digits so that the result is a power of 2? If yes, return true, otherwise return false. First, I want you to think about what structure matters here. Reordering digits doesn't change how many of each digit we have. It only changes their order. So what really matters is the multiset or frequency of digits. If we can permute the digits of n to become a power of 2, then the digit counts of n must equal the digit counts of that power of 2. Let's quickly check both example cases to build intuition. Example 1, n equals 1. The digits are 1. That's already a power of 2. 2 to the 0 equals 1. So answer is true. Example 2, n equals 10. The digits are 1, 0. What permutations are possible without leading zeros? Only 10. The 01 permutation is invalid. Is 10 a power of 2? No. So the answer is false. A slightly more interesting example, n equals 46. Check permutations. 46 and 64. 64 equals 2 to the 6th, so we can return true. Now let's consider brute force. We could generate all permutations of the digit string, skip permutations beginning with 0, convert each to integer, and test whether it is a power of 2 using the common bit trick. X is graded to 0 and x minus 1 dash 0. That's simple to implement and good for small sizes, but permutations grow factorially with the number of digits. For up to 10 digits, you might generate up to 3.6 million permutations, large and wasteful. There's a cleaner trick. Because reordering only changes order and not counts, we can compare the signature of n, either a sorted string of its digits or a 10-element digit count vector, against the signatures of all powers of 2. If any signature matches, we have a permutation equal to that power of 2. Why do we only need to check a few powers of 2? Because n les lead on 10 to the 9, the largest possible power of 2 we might reach is 2 to the third 29, equals 536,870,912. 2 to the 33rd is greater than 1 billion, so we only need powers 2 to the 0 through 2 to the 29. That's just 30 numbers. Implementation is straightforward. Compute s equals dash dot join nor dash 0. For each k in 0 dash 29, compute sorted 0 1 dash dash k and compare. If any match, return true, otherwise false. Time complexity is tiny, at most 30 comparisons, each working with at most 10-digit strings. Using a digit count vector avoids sorting and becomes linear in the number of digits. Space is constant. To summarize, brute force permuting is intuitive but factorial and not optimal. The correct and elegant approach is to use digit signatures and test against all feasible powers of 2, 0.29. This method is fast, simple to code, and handles leading 0 concerns implicitly because the target power of 2 strings never have leading zeros. All right. Now we're going to implement the optimal solution in Java using the same sorted digit approach. Get the digit signature of n. We need a helper method to get the sorted digit signature of any number. This will store the sorted digits of n as a string. Loop through all powers of 2. We know n is inequal 10 to the 9, so the largest power of 2 to check is 2 to the 29. That means k goes from 0 to 29. Check signatures against powers of 2. Inside the loop, compute 1 lentigo/k, bit shift to get powers of 2, sort its digits, and compare to s. If we find a match, we return true immediately. If no match found. If the loop finishes and no match is found, return false. Helper method to sort digits. We'll write a sort digits helper that converts the number to a character array, sorts the array, returns a new string.